Okay, hello everybody. Okay, today we will be at the last section of forces. Okay, dynamics, we call it. Okay, chapter 3.4, if I'm not wrong, friction and free body diagram. Yes. Okay, now let's look at friction. What do we need to know for friction? Now, for friction, right, the section that the textbook has categorized is under friction, the basic of understanding of what is friction, positive and negative friction, followed by its effect on individual objects. Okay, so for friction, right, as we all know, is that definition of friction is the force or whatever the contact force that tend to oppose the motion. Okay, now the important thing about for friction is that it always occur between the contact surfaces. Okay, not on the object or not against, not above the object. It's always in between the surfaces. Okay, so if we, let's say for example between tires and for car, in between the tire and the floor and the road, okay, the friction will occur in between the surface whereby the tire meets the road surface itself. Okay, and most importantly is that when we say rough road have higher friction. Why rough road? It's because for rough road, okay, they have a lot of irregularities on the surfaces. And these irregularities, when the object move over them, okay, they tend to create small opposing force, which is what we call friction. Okay, but not all frictions are negative. Okay, in like maybe lower side or maybe primary school, we tend to relate friction as a bad thing. Okay, it causes wear and tear, it causes heat to occur. But not all frictions are bad. They are actually positive effects of friction. And we will look at it, one or two common positive effects of friction. Okay, the positive effect of friction that we actually use and see very often is, let's say for car, okay, when the wheels are rolling. Okay, for cars, the wheel, let's say this is the wheel, or even if you're pushing trolley, okay, you push forward. But what actually causes the wheel or the car to move forward? Okay, for example, you're pushing the car, or the car is moving to your right. Okay, so let's say the wheel is rotating clockwise, like what the green color arrow mentioned. Okay, so what we are looking for is when the wheels actually, what actually happens is when the wheels turns, okay, when the wheels rub against the floor. Okay, so what we have is the wheel is actually pushing the floor backwards. Okay, so the wheel is actually pushing the floor backwards. So for the wheel, okay, I will use different color. So let's say I will use a green color one. Okay, where's my marker? Okay, so let's say I erase this one first. Okay, so now what happened is, okay, so let's say for when I pushes the wheel, when I pushes the trolley, or when the car move, the wheels turn. Okay, the wheel turn. What it does is when the wheel turn clockwise, it will actually push the floor. Okay, so the wheel when it pushes against the floor, you push. Let's say the car is rotating clockwise. Okay, so when the wheel pushes the floor backwards, because the wheel is rotating clockwise. Okay, so this is the force exerted by the wheel on the road. Okay, so what happened here is that this is where your Newton's third law will come in. Newton's third law will say that when every action there's a reaction. So when the wheel push the floor backwards, the floor will actually push the wheel forward. Okay, so this is where the red color force come in. And this force is the force by the rods on the wheel himself. So when the wheel is pushing the floor backwards, okay, the floor is actually pushing the wheel forward. And this forward motion is what actually pushes the car forward, what moves the car actually. Okay. So in this case, right, okay, the car will be able to actually travel forwards, okay, due to what we call the positive effect of friction. Okay, so in this case, right, the friction here is actually useful thing because we need that friction to actually propel us forwards. Likewise, when we are actually moving, when we are walking on the floor, okay, we are able to walk on the floor easily, walk fast, all this is because when we actually when we walk, okay, our heels are actually pushing the floor backwards, okay? So the floor is actually being pushed back. Actually, when we walk, we are actually pushing the floor backwards, okay, which is this green color force, okay? Oh, let me change the red color pen to green color first. Okay, so what happened now is when I change, when we are walking, okay, we will tend to push, our leg will actually push the floor backwards when we want to when we want to walk forward. So what happens is our leg, okay, so our leg, people leg, okay, will push the floor backwards. This is what we are exerting. We are actually trying to push the floor backwards when we walk. And as a result, because of Newton's third law, the floor will actually push our body or our leg forwards. Okay, thanks to your Newton's third law, action and reaction. So this will be the floor pushes on the people. Okay, so your floor will push the people forward or push your leg forward, and as a result, you are able to walk forward. And this walking is what we call the positive effect of friction. And in this case, your friction is actually in both cases, the friction is actually in the forward motion, or what we commonly known as forward friction. But the fundamental definition for friction is still correct one, in the sense that the forward friction still opposes the motion. In this case, the motion that we are referring to is by the person. For example, with reference to the leg, okay, the motion that you are exerting is to the left. You are pushing the floor backwards. The friction is opposing it, which is pushing forward. It's just that the net outcome is pushing your leg forwards. Okay, so that's why the fundamental definition for friction, whereby you oppose the motion, is still hold one. It's just that in this case, you are exerting a backward force. The friction will be opposing, which indirectly pushes you in front, which is what we call forward friction. For negative effect of friction is what we always see very common. For negative effect of friction is whenever you have ball bearings, when your wheels is rubbing against the floor. Now your wheel is not turning, your wheel is rubbing. So your wheel is not rotating. So when it's not rotating, your wheel is rubbing against the floor. Okay, your wheel is rubbing against the floor. Okay, and you will have your wheel is not pushing, and it's not pushing the floor backwards. Okay, as a result, there is no Newton's third law to push the wheel forward. Now you are being dragged. The wheel is being dragged. Whereas because of dragging, you'll find that the friction is actually backwards. Okay, which is what we call the commonly see friction. And because it's backwards, it's being dragged, the friction actually causes heat to take place, and it causes wear and tear to the surfaces. Okay, and as a result, this is what we call your wear and tear in wheels. You see your wear and tear in wheels, you see your wear and tear in ball bearings. Okay, so this is one of the common effects that you see in in friction, negative effects. Okay, then possible reductions. If you want to reduce friction, okay, there is quite easily done. The negative effect of friction, okay, is your using ball bearings, using wheels, okay, slot them in between the wheels, or okay, for ball bearings, slot them in between, so that when you move, instead of one whole wheels rubbing, you have this ball bearing acting as mini wheels. Okay, or you can actually reduce the wheel size, make it smaller. Okay, so with less contact area, okay, you have less friction. The other last way of doing it is actually using lubricants. Okay, put oil. You can put oil on the surface, WD-40. Okay, these are oil that will actually lubricate the surfaces, resulting in less friction occurring between the surfaces. Or as a result, you reduce the friction. One not so common way is actually uses an air cushion. So instead of like you being in contact between the surface and the floor, direct contact, what happens is I will actually introduce a layer of air. Okay, this layer of air, what you have this layer of air in between the surface, meaning the object is actually floating above the ground. Okay, so that layer of air actually acts as a cushion to reduce the friction. One common example is your hovercraft. Okay, enhancing positive effect of friction. Okay, positive effect of friction. Okay, now, so what happens is your tread in your tire. This one usually you see in your tires, your treads in your tire. Okay, so this tread, what it does is it actually channels the water out of the car, out of the tire. Okay, so when it's raining day, you find this tread are actually like small groove or small drain like that for the water to actually seep out of the wheel, seep out of the contact area between the wheel and the floor ASAP. So when the water are able to seep out as fast as possible, it actually increase the tire grip on the road surfaces. Less water, less slippery, or what we call more friction. As a result, your car will not skid so easily. Okay, likewise for parachute. Okay, parachute, you have more friction. Yes, I definitely want more friction, because when I open up the parachute, the air resistance, the friction between the parachute and the air is actually what slows the parachutist, what slow me down when I'm dropping from the air. So I definitely want that positive effect of friction. Okay, for parachuting. Yeah, for chalk, when you're writing, same thing. Writing, walking, and maybe pushing and car moving, they are all the same positive effect of friction. You need that friction, okay, for that writing, for the walking action to occur. Last section we look at is free body diagram. When we look at free body diagram, what exactly is free body diagram? Okay, free body diagram here we are referring to is we actually break the objects into individual objects, okay, on each object. So let's say we identify there are two objects in the question. So what we do is we will separate this object mentally, okay, not physically. We just imagine they occur. We just push them aside, okay, mentally, and we look at all the force examining on that happening on them. Okay, and after that we will look at, we see whether how can we use math, like example Newton's law, formulas, all this to solve whatever unknowns that we are required to do it. So Newton's free body diagram is more like a technique, whereby by breaking the body apart, I can actually derive more equations, and because of we have more equations, I'm able to solve more unknowns, or actually some of the third law reaction, the reaction pair forces will appear, and you will be able to examine it. For example, this, okay, suspended in string, okay, box suspended by strings and rockets in mid-flight. These are example of free body diagram, whereby they are actually, for example, box suspended by string. In actual fact, okay, you may have actually a box suspended by string. So this is actually physical string. It's actually physical string. Okay, so what free body diagram does is I actually mentally, in my mind, not actually I go and dismantle. Okay, so mentally what I do is I will actually dismantle the string. Okay, I will let me use like the color first. Okay, so I use okay, this one. So mentally I will actually dismantle the string from the box. So I'll just look at the box itself. So I'll look at the forces exerting on the box itself. So if I look at the box itself, the box is still physically attached with the string or this thing. So I still need to account for the forces of the string. So the box, this is the box I'm looking at. Okay, and because the box is attached to the string, on the box there's actually tension by the string. This is tension by string on box. Okay, these are the forces. These two tension are the forces acting on the box by the string. Okay, so the direction is still there, and I will still have the weight, even though I mentally detach the string and the box. Okay, the box is still subjected to gravity, so gravity is still pulling down. Still, there is still weight. So in this case, this free body diagram of a box, means the box itself only, actually is subjected to three forces: two tension, one weight, and this is exactly the force that is actually being subjected in real life. Okay, so when I do free body diagram, I'm actually removing it, and I want to examine each of the forces up close in relationship with using mathematical equation, all these things. But what actually happens when I separate the objects? Okay, the forces acting on it supposed to act is supposed to act one is still acting on the objects. Okay. Likewise, let's say we have an example of this. Okay, the rocket in flight. Okay, it's quite a simple one. When I drop down, okay, when I drop down, when rocket is in flight, okay, the engine is pushing. The engine is actually the real picture. Let's say the actual picture is it could be a rocket. Maybe I have a propulsion system here. So the propulsion system force here. Okay, the fire is here, is blasting here. So it's pushing the rocket upwards. So what happened here, if what I did was I actually separate the rocket maybe from the engine, from propulsion engine. So I will just have the rocket, which is here. So the rocket itself, the weight acting on the rockets, okay, I mentally dismantle the rocket and the propulsion already. So the forces acting on the rocket, I definitely have the weight of the rocket, and the propulsion system. Okay, when I fire my propulsion system, the propulsion system is actually blasting out, and because of that, it's actually pushing the rocket upwards. So the upwards force here is due to the engine or the propulsion system. This is by the engine. Okay, so the upwards is forces of the engine acting on the rocket itself. Okay, or the propulsion system acting on the rocket itself. Okay, so remember what I did was before all this, I actually have a free body diagram. I actually detached the rocket from the engine or the propulsion system. Okay, then the last one I have is while I'm going up, I actually also encounter air resistance, which is opposing my motion. My motion is upwards. Air resistance opposing will be downwards. So if you look at the free body diagram of a rocket, which is the rocket itself, I actually have three forces acting on it, which is Fe, weight, and air resistance. And from here, I will actually apply Newton's law to solve the question itself. So we'll look at one example to see how we do it. Okay, an object is 700 kg, engine force is 5,000 Newton, and there's a friction of 100 Newton. So draw a free body diagram to show how the car, what are the forces acting on the car itself. So the one that we are looking at is if I have a car, okay, if the car is moving on the road, there are actually a few bodies we are looking for. The bodies that we are looking for is actually this. There's actually the car body and actually the ground. Why? Because for the car to move, the car, like I mentioned before and earlier, the wheels of the car must actually push the ground. As a result, the ground will be pushing the wheel forward. So in this scenario here, although I mentioned car, but if you look at the free body diagram, there's actually two person here, two body here. One is the car, one is the roads. Okay, so forces are acting on these two different objects, two different bodies, okay, for this singular action of car moving on the road. But because the question asks for the car, the forces acting on the car, so we'll focus on the car. Now, for the car, okay, the car itself, this is the car. So the most obvious one is I will definitely have a weight. The weight is by Mother Earth. Okay, the weight is Earth force. This is the Earth acting on the object here. Okay, the Earth acting on the object. Okay, give me a minute first. Okay, so when the body that we have here, we have your weight, which is the Earth on the box itself. Okay, so at the same time, the box is actually sitting on the ground. Okay, and as a result of your weight, the ground will actually push the box upwards. So normal reaction force is actually the ground pushing the floor box. Okay, so when the whole thing lies on the fact that the car is on the ground. Okay, the car is on the ground. So when he is actually holding the ground, the car is on the ground. The car is pushing on the ground, and action reaction force will tell you the ground will actually push the box up. So the box will actually experience upward force by the ground itself. And of course, similarly, you have a forward force, which is here. And because of the forward force, you actually have the friction, which opposes the motion, which is here. Okay, so these are the four forces acting on the car itself. Okay, weight, normal reaction, engine force, followed by friction. So these are the four forces acting on the surface. But so what happened after this? When I have all the forces on the body, what can I do? I will actually want to use Newton's law to actually apply. Because at this moment in time, I actually have one body, but once I got all the force sorted out, I actually can apply Newton's law, F net equal to ma, okay, on the on the horizontal component. Okay, which I can apply Newton's law on the horizontal component. And at the same time, this will give me the one equation. Okay, so then what happens is I can actually apply Newton's law again. But now what I do is I actually apply it on the vertical axis. Okay, so I will apply Newton's law on the vertical axis. And because I apply Newton's law on different axes, it actually allows me to form two equations. So with two equations, I am able to use simultaneous equations or other mathematical tools actually to solve for unknowns. So that's the beauty of a free body diagram. It frees up the bodies and it allows me to apply Newton's law at different orientation. And because of that, I am able to form more equations. So let's say because I want acceleration, which is the horizontal component. So what I do now is I apply Newton's law on the horizontal component. Okay, so F net is resultant force. Okay, the car is moving to the right, so I take right as positive. Okay, so now total force is F equal 5,000 minus 400. So how do I get this equation? Okay, go back to basic Newton's law. F net equal ma. Okay, so what is F net? Like what I mentioned before, is force of engine minus friction equal ma. So this is 5,000 minus 100 equal your mass is 700 kg followed by acceleration. So if you rearrange the math, you'll find that the acceleration is 7 meter per second square. Okay, and with this, we actually solve the question. So I don't even need to use Newton's law on the vertical axis. Okay, so if I want to use vertical axis, so for vertical axis, I take up a positive. You'll find that I have F net equal ma, which happens to be the normal reaction force minus the weight of the object, equal to ma. Ma, but remember the car is not moving up and down, it's moving horizontally. So in horizontal perspective, acceleration is actually in the vertical perspective, the car is moving horizontally. So vertically, he's not moving anything. So vertical perspective, acceleration in the vertical axis is actually 0. He's not moving. So because of that, my reaction and weight equal to 0. You'll find that my reaction force and the weight is actually the same magnitude, which is true because your car is resting on the floor, which means the floor will experience the full weight of the car. And based on Newton's third law, the floor will actually reciprocate the same amount of force in opposite direction. So the magnitude is actually the same. And this is how I apply the free body diagram to solve, okay, physics question, to solve dynamics question. Okay, and that's the beauty of it. Okay, so if at any one time if you're not sure about Newton's law or even friction, okay, feel free to just pause the video and rewind back and to see what are the section that you need to listen again, or even check back with your textbook so that the video and the textbook can go concurrently. Okay, if not, you can actually leave me a comments, give me your comments at the bar below. Okay, then after that I'll get back to you ASAP. Okay, for the next video, all these things, if you want to get the latest update or the latest video, remember to subscribe to the channel, and after that switch on the bell button so that you get notification of any new videos that I uploaded. Okay, if not, thank you very much. Bye bye.